So therefore, nothing matters.
So if I gave you a problem like this, I would never have instructions say solve because this is not an equation. But I do get people do this, and then they give me this. And I'm like, how the hell do you know that? What could this equal? Anything. And these are the answers only if this is 0. But it doesn't tell me what it is. It could be anything. I don't know what it is. So that's why that would be a simplified question. Can't solve it. So don't make everything in the universe 0. So sad.
So 0. Everything is 0.
All right, I like it. Anything else? Yes? Okay, let's see. Here's a very specific question. 20x squared, what was it?
Minus 68 equal negative 44.
Like that? Yummy. So what is it about that equation that tells me I can't solve it the way we did before?
Because of equal.
No. Not, see, I said solve. So this is an equation. Why can't I just get x by itself and be done with it? Yeah, the x stuff themselves are not like terms. I can't do that anymore. You guys see that? So the way we build it up in the curriculum leads students to think certain things. But no, if I see an equation, if that wasn't there, what would you do? Divide by negative 60, be done with the damn thing, right? But I can't do it. I can't get my x's more together. They're not like terms, so I need a different way. Okay, maybe. Because the whole thing we were doing before was based on get x's by themselves. I can't do it anymore. They have to stay separate. So that tells me to do what? Yes, I want to get it equal to 0 because that's what this new process, when I have higher powers than 1, the new process says, oh, maybe we can factor it and use that 0 property. Weirdness.
Sorry, I forgot I have.
Oh shit, get out of here. Oh, wait. Might as well give you this. Where are they? Oh, good. Mm-hmm. And everybody else gets up. We all forgot too. So yeah, you gotta add 45. Another big mistake I see is somehow people actually put these together. But again, they're not like terms, right? And now, what do? Beautiful. Kick ass. I don't do 20 times 45. Oh my God. Right? So what can come out? And actually, to tell you honestly, I'm not even going to factor it. This is an equation. So I can divide both sides of an equation by anything I want to except 0. So what goes into all these? 5, yes. So if you divide by 5, I'm going to do it to both sides, make it all equal. Thanks for the help. And then, yeah. See, the 0 eats it up. Now that's a lot better to deal with, right? So how do you do? You do 2 ways. If you notice something here, there's a way you do it, but you can just do 4 times 9, right? That was almost 2 in your face to see. Factors of 36 that make 12. 6 and 6, and they got to make negative 12, so they both have to be. All right, that's a homework. I've done too much for you already. Let's just finish that bad boy out. Is that all right? So the higher power on the x tells me to get it equal to 0, so then I can try to factor it. Don't forget about GCF, my God. Because you totally could have done 20 times 45, 900, and then, that wouldn't have been that bad to be honest, 30, but still, why make the numbers bigger when they don't have to? And anything, this could be an hour of me staring at you. I'm not going to let that happen. If nobody has something for a while, I'm going to leave. Yes?
Going back up, when you added 45 on both sides.
Yes,
Okay, that cancels out the 45 negative,
good.
and why did you distribute negative 60 plus 45?
I can't, I didn't. So I added 45 to both sides.
Yeah,
20x squared minus 60x plus 45 is exactly that, because there's no like terms.
so you just bring down the 60 and put
Those
it
are there.
45?
Those are there, I didn't do anything with them, right?
Yeah, right.
So those are still there. What did I add to the side? 45. So it's still the same, isn't it? It's the same, I just added 45.
Okay, 'cause
Yeah.
you added it. and
I can't put anything together, no like terms, which you gotta check, but there weren't, so oh well. Now watch this, let me make a problem similar to that one. There's one little change in this one. Same step, same first step sort of, but now what am I gonna add? 45x. Now these are like terms. So what does that become?
15x.
Minus 15x. Get out of there. And now what kind of problem is, there's only two terms, GCF for damn sure. That's why you always try GCF first, because people will start trying to do this weirdness and it's not even three terms. It's not gonna work like that. Right? It's not squares or cubes. What's the GCF?
5x,
Yep.
4x, minus 30.
So then 5x is 0, or anyway, so you guys understand this is a different problem, but very similar. It just had something that was like terms, which is nice because then I got an easier GCF problem. But when they're not like terms, ah shit, 3 terms, ah shit, 20, not 1. Yeah. It's not like an ah shit, I can't do it. It's an ah shit, it's a little harder than I want it to be, but oh well.
Thank you.
Anytime. Yes.
Would you get the same answer
No.
for both questions? Well, I mean, like, if you took the GCF out and put it like 5x to 4x minus 3 rather than dividing by 5.
Oh, I see. Okay, so let me do this. All right, watch. This is kind of cool. You ready? I'm glad you're asking the question. So what if I would have not done that? What if I would have done this?
Yeah. Like, it's the same.
Now watch. You ready? Either 5 is 0 or this is 0. Can 5 ever be 0?
No.
So that doesn't give me any answers. That's why you can divide by a constant, because it doesn't take away answers. Here, if I divide it by x, so then I'm left with let me say divide by 5x. You with me?
Yeah.
Then I would have only gotten this one answer, but there was supposed to be another answer that I lost.
Okay.
But if I divide it by constant, I'm not going to lose an answer, because a constant can't equal 0 unless it's already 0.
Okay.
I like it. Good question. I like that. A question I really like to give. Hint. Is a question sort of like this here. What do you got, Jeff? I don't know, man. You're the one who brought it up, Jeff. What do you got, buddy? You can do it. Yes. Sure, I like it. Yummy.
It's 10x.
Yes, 10x, sorry. That 0 is really getting a little out of play. Okay. Stay in your lane, 0. Do you notice something here that I don't have to get it equal to 0? Why do I say that? Because what would happen to the terms? What are the terms? I pointed to it already. But what are the terms that tell me I might have to get it equal to 0? X squares. But what do they do?
Cancel.
Yeah. So anytime the reason that I have to do it that way isn't there anymore, now I can just do this like normal. See that? So try to take a second when I have an equation with a higher power than 1 in it, see if something with the higher power stuff will cancel. Because then you can just do it like chapter 2. Referencing the chapter in the book, I think that is about solving equations. Do you guys see that? That's an important thing to realize is I'm not we're not leaving behind equations that we've done before. No, we're adding a new category that we can handle now. Well, if it simplifies to an old cat, I could just do it. I don't need to make it equal to 0, right? I would subtract 5x, add 5, divide by 5, negative 7, done. Because the thing that would have made me make it equal to 0 in factor died, right? Sorry, I just think about this one guy was going to make you do something and then he's dead. And then you're like, I don't have to do that in text. That's terrible. Don't wish that on anybody, kids. Is that all right? So again, like hint, this just might happen on the test somewhere. I mean, notice, if you didn't realize that when you got here, and actually, what if you just started moving everything? All right, let's say you subtracted 10x and added 5. Then you get negative 5x minus 35 equals 0, right? And then watch. Take a negative 5 out. Right? So then x equals negative 7. Holy shit, right? So the new method has to still work. It's just a weird way of looking at things that you don't need if the higher power goes away, right? Sounds terrible. I've killed your God. No, if the higher degree term goes away. There you go. Sorry. It was a weird morning, so I'm just kind of enjoying that it's over, to be honest. And I like you guys a lot, so I like being here. So I'm a little extra goofy. Anything else you want to talk about from quiz practice test?
This is from 7-6 homework.
What's it say?
It's n squared equals 5 minus 6n. And then it says n squared equals 5n minus 6.
And it says try to solve both or something?
That's all.
Does it have instructions? I think I remember this one.
Solve quadratic equations by factoring.
And it gives you both of these?
Yeah.
Okay, so one of these is solvable, one of them isn't, but you won't know until you do the first step. So let me take this away for a second. Let me put it down. What was it? Equals 5 minus 6, like that? Okay. What do you have to do first here? Yeah, add 6m and so you get m squared plus 6m minus 5. And again, I didn't have to specifically subtract 5, I just had to make this side 0. So whatever's there, I want to kill it so that I get 0 left. Unfortunately, some people do that as if the whole side just like doesn't exist anymore. No, sorry. No, so it's still, no? No, okay, fine, that was for me. Snapped it away. What would I need? Some of you guys did that. Thank you, bro. What would I need for this to work? Two numbers that do what?
Multiply to negative 5.
Multiply negative 5?
Add to 6.
Add to 6. Since they multiply by negative 5, you can't use 5 and 1, right? Because that doesn't multiply to negative 5. One of them has to be negative. The minute one of them's negative, he's screwed. And that's, as far as I know, that's the only way to factor 5, using whole numbers. Okay. So that's the one that's dead in the water. The other one should work. Is that all right?
Yeah.
Yeah, so one of them ends up with something we can't solve yet. Some of you guys I know quadratic formula. Guess what we don't officially know and therefore you cannot use? Quadratic formula. I don't want to see that shit. We don't know it officially yet, so don't use it.
There's no number in front of the exponent. Then you just, okay.
Yeah.
Instead of the other one where you multiply.
Yeah. So when the first number is a 1, that kicks so much ass, because then the only things I don't know are the two numbers at the ends. So, and that surefire method I use will work if the first number is a 1, but it's like, why the hell would you do that shit? So, for example, I've seen people do something like, what, Jeff? Bring it. Or not even that, let's just say I've got a factor, all right? So they'll go through all the trouble. What do I need? Two numbers that?
Multiply to 48, add or subtract 48.
They add the 14 because they both have to be the same sign, right? They have to multiply to be positive. Both going to be negative. What are they?
Negative
Negative. What numbers make 48 and make 14?
12 and 2. Or
12 and 2 is 24.
24 and
24 is too much. I'm sorry, Spencer. I don't mean to be coming down to you. Appreciate the attempts.
6 and 8.
6.
6 and 8. Kick ass. And again, it's interesting. When that number is positive, it matters later what that is, but if that number is positive, they both have to be the same sign, so they both must actually add. If that number is minus, that number can get stupid big or something, because then they just have to subtract to be this, or get really small, right? So I can't do this. What do you got, Jeff? You can do it, man. Leave me alone. There it is. I can't do that, but I can do that. Because here it could be 4 and 5, and if the 5 is negative, hey, it can make -1. Here, they have to both be the same sign and add to be 1? How the shit? Do you see what I'm saying? And again, what I'm saying right now is not necessary for you to be able to do these problems. But the more you kind of get what I'm saying, the quicker you'll be with some of these. That one I can identify as prime really quick. Ain't no numbers that make 20 that also add to be -1. They're both positive and they're both bigger than 1. Or one of them is at least, right? Anyway, side note, sorry. Coming back to this guy. I have completely forgotten what my point was going to be. I had a point. Oh yeah, that's right, that's right. I see people do this. Right? And it's okay if you do sort of is okay, but it's just too much work. And then you do this, and then you do this. No, you gotta be minus. There it is, Jeff. Correct as you go. All right. Holy shit, you didn't need any of that. 8 and 6 are right there. 8 and 6, right? And they're both negative to make -14. So I'm not going to take points off if you do this, but you're just making the test longer than I intended it to be at that point. Why did you make this step? Well, you did every problem with extra steps. That looks like algebra just with extra steps. I'm not saying it's wrong. Again, if you do it, fine. If you do it a lot, you're losing time.
You need explanation. You need explanation.
It's a what now?
You need explanation.
Oh, no, but I don't need this because when there's a 1 out front, it's supposed to be a relatively quick. I still want to see this. I do kind of want to see in your head a little bit. Show me something. And there are too many people still that are doing problems like this and just getting to the answer with nothing. I'm like, that's no. Right? Did it on my head. Oh, it's too bad for you. Get something on the paper because I'm supposed to grade stuff and there's just nothing. So you will lose points. I might wear my, I don't know if tomorrow I can wear my show your work. I got a stupid meeting. Anyway. Huh? I know. What have I haven't done my life correctly, kids. Don't get to a point where you have so many freaking meetings. I'm a teacher, not an administrator. Anyway. I don't even know where the one tie is that I own, so I guess it's not that bad. If I have to go to a wedding or something, like, where's that damn tie? I actually had one of those, but no, I have a real tie now. I go to YouTube so I can remember. Oh yeah, rabbit hole shit. Okay. That's all. I'm sorry. What else we got is, yes?
H on the practice test.
Maybe you still need that practice test, by the way? Oh, you were here earlier.
Is there an answer key to that?
Somewhere. I got one. I'll give it out later. You know how they work. So which one, sorry?
H.
Oh yeah. That's the yummy. What is that? 1H? What form is that in? How many terms are there in 1H? 2. So what could it be? First off, any GCF. Even before you think about what it could be, no GCF. So there's 2 terms. It could only be squares or cubes. It's got to be cubes. What do you see in there that tells you it's cubes?
6s and 9s.
6 could be squares, right? You cut it in half, but 8 is a cube number. 27 is a cube number. 9 is 333. Blah, blah, blah. So everything can be cut in thirds. I like that. So what do? Do what I just said, right? Cut everything in thirds. So 8a6 would be
2a squared.
2a squared, 2a squared, 3b cubed. It's beautiful. And symmetry there. I like it. Okay, got it. Right? 2, 2, 3, 3. It's beautiful. You don't have to use that word. Sorry.
Keep going.
And then what do I put down here?
2a squared.
Mm.
Plus those guys, little guy, big guy.
Yeah. Just humor me.
And then
And now, yeah, all right. Now again, if you've missed some classes, you probably want to go watch those videos, right? Because we did discuss the idea behind cubes, how it's very similar to squares, right? If I had a square situation, what do you got, Jeff? They make kind of an associated square situation. What would this be? Why is squares relatively easy? Because I just cut everything in, and that's it, really, right? Cut it in half, cut it in half, put the same shit over there with a different sign. So that different sign is actually related to this one being a different sign. They're the same exact idea. It's just that over there I'm going to be unbalanced, right? Here it's perfectly balanced. So there's no need for some extra cleanup term. Here, one of each, two of each, that's why the cleanup term exists, because now not everything goes together perfectly. This one, the middle terms go together perfectly and kill each other. That one ain't going to happen, because it's not symmetric correctly. I don't know if you guys get that at all. So help me out. See, Spencer, you started doing it. What goes in the little dude?
2a squared.
Yeah, one of these.
And one of those.
Plus, I like it.
3b.
Plus, I like that. It's like both at once. 3b cubed. So then what goes here?
4a.
4. You can double check. There's my 8a6, right? 8a6. What goes at the end?
9.
9b6. Beautiful. And then I can get my 27b9. And then the middle term has to have what sign? Minus. And then what is it going to be? 6. A squared. B cubed. That's the part that people don't really trust. But that's the part, that's what makes all the extra shit cancel. Only want two things to survive this. Without that, I get a lot of other shit I don't want to survive. So that guy kills all those extra little bits. Yes?
How did you get again the negative 6a?
Negative 6a squared b cubed? That one, or where we?
B cubed, B.
Which part are we looking at? This part?
Yes,
Okay.
how did you get that?
2 times, you multiply whatever's in the little dude. 2 times 3 is 6, a squared b cubed.
Got it.
The middle guy is always the product of these two. One of each, two of each, product in the middle. As close to a song as I'll get pop. And again, it kind of, why is there one of each here and here? Because there's 2 total. So it's got to be 1 and 2. 1 and 2, because there's 3 total. And then not everybody's going to like go together right, so then that's what this guy does. Kills all the extra what we call cross terms. Because real quick, the reason I call them cross terms is that is there. That is there. The cross terms, these terms, are the terms that are freaky shit, right? Okay, maybe. What else you got? Where are we at? Man, they supposedly fixed the AC, and they're like, we don't want to turn it on because it might break. Like, I don't want to take my car on the road because it might get messed up. Why'd you buy the damn thing? Trophy.
Okay, you do 2b.
2b.
Yeah. It's x cubed equals 16x.
So again, what part of that problem tells you how to solve it? It's an equation, but why can't I solve it like the old days? Why do I have to solve it in a new way? Cube. There's a higher degree. on one of my variables. Are these like terms? No. So it's kind of weird. They're not like terms, so let me try to put them together. But the main idea is get it equal to 0. Because then I can factor and use that whole factor property. So the first thing I got to do is, how do I make a 0 here? Yeah, subtract 6 units. And then, of course, what do I do with the resultant thingamajig? Yeah, start to factor it, in this case, GCF. So if that wasn't there, I would have just subtracted x, divided by 15, been done with it. I could get my x's together. My x's can't go fully together, so I want to get it equal to 0 and try to factor it instead. So how do I, like you guys said, GCF? That changes everything. And then what? I can go further in that, dude, right?
X plus 4, X minus 4.
Yeah. So I get my 3 answers I expected from the beginning. I get x equals 0. Yeah. -4. +4. And again, the step I'm sort of skipping is each factor studied equal to 0. Bam, that's an answer. Oh, P. And then x plus 4 equals 0. Subtract 4 from both sides. That's where I got -4. So that equal to 0. Add 4 to both sides. That's where I got 4. But it is akin. There you go. It's akin to finding out what goes into the penalty box, right? It's the whole idea of what makes it 0, and there it is in your face now. We're making it 0. Yes. What is it, sorry? Oh, the x squares went away. Oh, you could do it. No, it's not 140, it's 40.
Okay.
That's, yeah.
I cancel x.
Good. And then you're not in a new situation. I don't have to factor. I can just get x's on one side, get numbers on the other side, like the old
Would you
ones.
see F on both sides?
You don't have to do it that way. I just wanted to show you that it would still work. So again, if I have an equation, here, let me make it even freakier. Why, Jeff? Because. What you got, buddy? No, let's not do that. Yeah, look at that. Look at that. Behold this grossness. Hereditary. All right. So we got x cubed plus x. What am I going to do on that side? And what do you notice?
Cancels the cube.
Yeah, the x cubes cancel. So now I can just add 7x, put my x's together.
0.
And so x is 0. I can just start to solve it like normal. I don't have to try to factor anything. I can just get my x's on one side, my numbers on the other side. Because the part of the equation that would have told me, oh, you need a new method, you need a factor method, canceled. I really want you guys to see. The old way of doing equations is not an old way. It isn't. It's just our first way. And now we've added more to our list. Right? So if those cubes would have stayed, I would have tried to factor, get it equal to 0, factor it. But I didn't have to because they died. And then I just look at it more like a normal problem from before. Yeah. Yes? It's like, we don't have a door there. I'm not sure what to do. All right. What was I gonna do something? Shit. Oh, watch this. Do you guys remember this question from before domain? Remember that question? How do we do this? What's the domain in this? Well, domain is all the x's I'm allowed to use. So what's the only x I'm not allowed to use? 4. Isn't that very similar to what we were just doing? What makes this 0? 4. So x can't be 4. You guys with me? What if I gave you this one? What's the domain of this? It's only 9.
Can't be positive or -3.
Yeah, because what do I do with the bottom to see what makes it 0? I factor it so I can see what makes it 0. So now there's two things, x can't be 3 or negative 3. So that's another thing factoring does for us. You're like, I didn't need that to do that for me, Jeff. Yeah, you did. You will.
Maybe it's the test.
Huh?
Maybe-
No, this will not be on the test. I just wanted to put that up there real quick as a little bonus motivation for learning factoring now. Because I think I told you, everything after this basically is going to somehow involve factoring. Oh yeah, this is going to be in the next chapter. I think the next chapter is rational equations and rational functions. You know how these days go. I don't bring anything. It's all on what you want to talk about. So if you are otherwise prepared for the test, we don't have to sit here, but it is up to you. And I love it how everybody's like, somebody might ask something good. So I'm going to stay. Nobody's saying it yet. So. Yes?
The notebook, there's a question about bugs and,
Oh yeah, turning the sides up and shit?
yeah.
Don't worry about it. No.
Can you do 16 PQ equals 24 P squared?
What is it, 24?
24 P squared, yeah. Plus 9P.
Ooh, that's yummy. Okay. I love it. Just wait till I'm like 20 years older saying, oh, that's yummy. You're being even creepier somehow. All right. What is it that tells you how to do this? Yeah, there's higher powers, higher degrees than first degree, right? There's cube and square. So I got to get it equal to 0. And what you normally do is you want to get the highest degree term positive. So I'm not going to subtract, I'm going to subtract these. Okay, so I'm going to get 16p cubed minus 24p squared minus 9p. Is that cool? I just subtracted that. No? So I did this, 24p squared minus 9p. So of course those cancel and minus 24p. What was it, 24p squared? Minus 9p, bam. Do that to both sides. Got it equal to 0, and now what do I do?
Just take out a P.
Yeah, start to factor, right? Take a p out. Get anything else